All right, thank you, Eric. As you mentioned, this is essentially the data set, the radiocarbon data set that we were talking about making last May. It's a progress report on what we've been up to. No. Oh, yes. Okay. Oh, sorry. Okay, so the motivation behind this project is essentially founded in the People 3000 objective, which is to compare human population dynamics with socioeconomic ecological systems. Um, and we've, as a group, have generally selected radiocarbon as one of the best representative of human population dynamics in the past. And the goal of this project is to synthesize all openly available carbon-14 data sets in a reasonable way. So a lot of the data sets that we've gathered have very heterogeneous data collection and storage practices, different data that they collect, different ways that they collect it, all of these things. And the goal of this data set is to produce one global radiocarbon data set that meets all of the FAIR qualities Wilkinson et al. Talked about in their paper in 2019, which is it's findable, it's accessible, it's interoperable, and reproducible. The last two are the most important. Interoperable means essentially that someone can take this data set and use it without having to do a laborious process to actually begin any use with it. And reproducible means that they should be able to, if they do the same methods that our group used, they should be able to produce the exact same data set. So this data set meets these criteria, and it's every single date within this data set should be unique. There's only one in there, which is a big problem that we've seen. And there's a big emphasis on spatial accuracy. So a date that says that it's in Greece should not be actually located in Russia, for example. So there's two major phases to the construction of the data set. One is a manual process. This flowchart on the right is sizable, but that essentially is the reproducibility. I want to draw your attention to this box in the upper right. We went for every data set we gathered. We went through and we spoke to some of you guys and the other data set producers to essentially establish a location accuracy method for each data set, and then we went through each date within the data set, all of the data sets, to verify that these locations were accurate. And this is a 0 to 3 scale, with 0 being no specific locational information, 1 being generally accurate to province or state or country, very close locational information, or exact. Most of our data, as you can imagine, are between 0 and 2. There are very, very few 3s. This kind of gives us a baseline to be able to say that the data that we are presenting are to this extent accurate. So we did an exhaustive review to essentially verify this accuracy with increased intensity in Europe because of the number of duplicates they have. Like some dates exist across all these data sets 16 times, and we need to deal with that. So after we did all these manual processes to verify that that the data set was in some reasonable shape, we are then able to do an automated process, which Lux is going to describe for us. Lux?
There we go. So yeah, this is essentially the protocol that we started working on right at the last Vernal workshop. You may have seen me maniacally typing away at my keyboard. This is what was going on. It's all written in Python 3, and essentially it takes the big mushy data set that Darcy has created from the process she was just describing. We go through to first purge any records with unknown lab codes. We simply maintain a list of all of the known lab codes and the countries that they're in and the name of the lab, and sometimes a little bit more information than that. We can then standardize the coordinate formats. Sometimes they're northing, easting. We switch it all to just decimal lat longs. There's a lot of duplicate handling that has some specific rules for it going on. The kind of biggest things going on there is prioritizing the location accuracy and making sure that there's really just like no bad or anomalous data. And then lastly, there's just a couple of miscellaneous things that the program has to handle, limiting dates so that we're not pulling dates from the future when they have negative BP dates for them. And I think we limit it to 43,500 BP, as that's the upper limit for beta analytic. Back to Darcy.
All right, so after doing all of these processes, the manual and the automated, we finally had a data set that is global, and as you can see, generally all of the, this is the global map, and it's color coded based on country, and generally you can see that all of the countries and all of the data within the countries line up to the continents that they're supposed to be in. This is a laborious process, and now that we've gotten this, the next step is essentially to construct some form of quality analyses to see like at what accuracy can we actually analyze these data. And because we have a global data set, we started from a global scale. So this is a kernel density model. It's constructed using like the default kernel density radius that Mark selected. And as you can see, there's low density of radiocarbon dates in most places except Europe and the Western US, because there's just so many dates located in Europe that they just outclass all other spatial densities around the globe. So because this is a global data set, we don't want to present this as something that you can like essentially plug and chug and automatically do things on a global scale without adjusting for Europe. So regional scales or even more local scales might be more effective if you don't want to adjust for Europe and the Western US. And what size of region varies. So here's two different locations. On the left, we have northern France, and on the right, we have the Netherlands. Essentially, these are located in Europe, and they have like a decent level of data gathering because they're in Europe and there are some standards. But these, and they're geographically close, and they're geomorphologically similar. These are data that Mark gathered from CRM reports. So it's not the entire data set. It's 30 years of CRM reports. Essentially, what were people gathering? And you can see on the x-axis we have from 6,500 before present for both of them until 0, which is present. And the top is the SPD. The middle for both of these is the same. It's a model produced by sampling the data themselves, and if it's red, then it's above what you would expect based on the model, and if it's blue, then it's below. You can see here that in France, there's very few places that are above and very few places that are below. The important thing to realize, however, is that around 2,500 before present, so 500 BC, there's a cultural shift to the production of very distinctive bronze tools that are used as a typology to chronologize the site. So instead of having to do radiocarbon for anything post 2,500, you can instead use these bronze tools and roughly date the site. And you can see in France, there's less radiocarbon dates produced after 2,500, versus in Netherlands, there's generally more. So these graphs on the bottom, the top line is the number of sites that are considered at this date. The dotted line is the Arist weighted values Alessio has talked about, and the gray dash is the modeled Arist values. You can see the number of sites after 2,500 does increase significantly in both locations. These are very, very similar graphs. But the sampling of radiocarbon decreases in France after bronze is adopted, versus it stays consistent and accurately represents the population. So this is a situation where the population is doing one thing, the archaeology, the humans on the landscape are doing one thing, and then the sampling of these data is misrepresenting what people are doing if we were to just look on a radiocarbon scale. So in conclusion, we have a couple more things that we need to do Lux has been working very well on fixing Unicode errors in site names. So a lot of data sets have been saved in a format that doesn't actually preserve the Unicode format. So if you have like an accent in a site name, then that'll dissolve into some weird thing. There's a few small duplicate errors we need to fix. We have to do further quality assessments between and within continents. We just showed you the global scale and a small sample in Northern Europe. We've done several other locations, but the goal is to do this in many locations for the eventual publication. After these things happen, we should have a draft that we would like to submit to publish on send on Google Drive. So that way, all of the co-authors, of which all of you are co-authors, can review the document to confirm that you're cool with it, upload the data set, and then finally submit to scientific data.
Thank you, Darcy. Yeah, any questions?
Yeah, you have a question?
Yep.
So how this kind of data will be published? So all of them will be published on Zenodo? I mean.
Yeah, so we have, I think, Alessio, we've spoken about your data specifically in terms of,
in terms of my data.
Oh, no, just in general?
In general, no, because
yeah.
My only concern is that if you get all kind of data from all digital repository, but this is a problem that I've been thinking for years, because it's there is no a protocol, or if you know, maybe I'm not aware. I mean, there is the risk that imagine you are collecting all of this kind of data from already digital repository, and then you publish the whole dataset. What could be the problem with the holder of other repositories? They could say, you have taken this big amount of data from my digital dataset, and then you are publishing under your name. Because this is a problem that we had in the past at UCL. By using data from other digital repository, we quoted the people put in the reference, but some people were complaining. So it's just a matter. So are you going to, I don't know, because yeah, this is the problem. There is no protocol. And because there are a lot of digital repositories available now, when you come with the collection of all of these kind of repositories into big one, which is, I think is good to have, there is the risk that the holders of other repository could say, now they will not quote anymore, for instance, Mr. Brown dataset, but now it's under the name of blah, 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 et al. This is my concern, is just because there is no protocol. So
yeah.
It's a way how to deal with this problem, because it's just a problem that, for instance, I face when I deposit, for instance, also for the nearest. We have this kind of database we would like to publish, but they have been collated by reports, but also from digital repository online.
Yeah, our goal. So our goal with this data set. So we have like these four people, myself, Lux, Mark, and Eric, are essentially the people that are kind of spearheading this project. The et al. Generally refers to the people, at least one person that has produced the contributing data sets. So we've been asking for permission to publish from someone who's produced these original data sets. I do agree with you that there is a problem in mismatch. For like, Europe is a big thing. For example, like there's the context data set, which is one of the oldest ones, and then most other European data sets actually consolidate dates from the context, and then people continue building it without realizing that the context is the original data set that produced it. We actually as part of Lux's automated protocol, we do actually prioritize the older data sets, assuming that their data is less likely to experience copy errors, and also that they're more accurately representing how they gather these data. In terms of accurate citation of the original contributors, I do think that all of these steps modify these data sets enough that it is its own work. And I think that by having an author or included on our author list should help mitigate that. But I don't know if we want to have literally all the people who've ever collected radiocarbon dates listed as authors. If that's what you think would be more appropriate.
So I just want to add that, you know, we're only using data that has been published already. And so the best that we can do is to cite those original propositories in our data forms, right? And, you know, mention in the publication that exactly what Darcy's just articulated, that we advise folks to not only use the data set that we're producing, but also you know, go back and refer to the original data set in whatever region that was originally published in. You know, our main objective here is, and as Darcy mentioned in the inspiration, is that a lot of the data sets are not interoperable right now. And that interoperability is a major problem. And so that's the real benefit of what we're producing, is that we're producing a synthetic data set that enables folks to then go in and work with on their own. You know, I don't see I think as long as we're citing the original databases, I don't see another way around that.
No, I agree.
I would like to add really quickly that so we're studying the original data sets, and then the data set itself does have a column that lists essentially all of the data sets that had this date located within their data sets. It's a column that lists all of the contributing data sets that had this date within it. So if it's in context URI-val 14C, etc., then they're all listed within that. So people therefore can use the data set and can refer to the original data set themselves.
Yeah, there is the original. Okay, it's good.
And I want to go back, Darcy.
Yeah, it's saved.
Darcy, can you go to the final slide, the conclusion slide?
Oh, yes.
Because there's something else that I would like to highlight. So we're uploading this full data set. You know, part of the problem with interoperability, reproducibility, or even actually findable, accessible, so the first two aspects of these FAIR principles, is that oftentimes people have their go-to locations when they're looking for a data set, right? And one thing that we're trying to do is we're trying to spread out the publishing of this data set. So we're not just going to put it on our page's website, for instance, because we can't trust that, or not trust, we can't rely on the rest of the community, the research community, knowing where to look, right? Knowing to look at our page's website, right? So for that reason, we're going to spread out this data set as much as possible to make it more findable and accessible for other people. You know, so that's just one thing I wanted to add. Yeah, we've all worked with these data sets where we know that to get anything done, it's an enormous amount of cleaning that we have to do to really initiate our analyses. And I think that's the major motivation of this exercise, is to make it easier for folks to not have to clean the data as much as they would typically need to. That's not to say that they, as Darcy pointed out, there are biases in the data, right? We're dealing with archaeology, right? Archaeological data. So there's going to be biases. And so part of our job in doing this is to kind of highlight advice about using this synthetic data set. and always giving credit to the original producers.
You might simply be able to put like a recommended or give some language as to how to make those citations when you make those data in the data set available.
Yeah, one of the reasons we're submitting to Scientific Data is because one of their sections is actually like recommended use of data. And they require these quality analyses that so I think that we can present the quality analyses that we do and essentially be like, hey, if you're going to use this data set, and you're looking at a region that we didn't specifically look at we will make the code available to do a quality assessment of your own. And then people will be able to be like, oh, well, I didn't look specifically in a region that the P3K group published on and had graphs on, but I can take the rows that I want, take the lab numbers that I want based on whatever geographic or temporal area, and then use the code that we published along with to do these sorts of analyses, as well as other analyses, to be like, oh, I can see like before they even start analyzing the data, they can see, oh, I can already tell I'm going to have a problem in France. And so I think we're not just publishing a data set, we're also publishing Lux's code, and we're publishing the quality analysis code as well.